Well, hello, everybody. Thank you for coming today, both in person and virtually, wherever the camera is. I am very happy to present my interns and introduce them to you today. We have Amanda Bevans and Amber Staples here today, and both are recent graduates of University of Maryland College Park. And they both did intensive work with me this summer, all summer, both mentally and physically, on the crab survey physically, and at their desk, trying to crunch numbers and do new data analyses of our long-term crab survey, the longest crustacean survey I know of. And you'll hear all about that in a few seconds. I did want to tell you a little bit about these guys. They are both really hard workers. Together, I refer to them as the A-team. And I'm very excited to say that they will both be continuing on with us in different capacities into the fall and beyond, hopefully. Amber will be continuing to work with me on the crab survey as a technician in the fall. And Amanda will be joining us as a graduate student with Morgan's Integrated Science Master's Program. So very, very excited to present both of these guys to you. And without further ado, here they are.
Thank you, Tom. Good morning, everyone. Thanks, Tom. Yeah. Good morning, everyone. Again, I'm Amber Staples. I'm Amanda Bevans. And as Tom mentioned, we did do field work and some data analyses for Morgan Pearl's Blue Crab Survey. So the survey has been going on for over 50 years. So today we'll be sharing with you our findings from our research that we completed.
So we're going to begin with an introduction to the blue crab, or Callinectes sapidus, which literally translates to beautiful savory swimmer. So kind of aforementioned in its name, it is a swimming crab, meaning that it's not confined to the benthic or bottom environment. You can also find it within the water column, so swimming around. It is native to the western portions of the Atlantic Ocean. You can find it as far north as Nova Scotia and as far south as Argentina, but is primarily found within the tropics to the temperate zones. We are in a temperate zone as well as Chesapeake Bay, and the blue crabs play a really important role to our Chesapeake estuarine system. So they are a scavenger and a predator of the benthos, and they play a really essential role in the structure of trophic systems in the bay and are considered a keystone species. They utilize all of the bay's habitats from the bay mouth to the tributaries. You'll find them in the shallows as well as the deeper channels. A little bit about their growth and reproduction. So they molt to grow. So they shed their hard shell while they are soft. They expand and increase in size, and then they harden again. From about spring to fall, they're going to be mating and spawning. And on the next slide, we're going to go a little bit more into depth about that. So the life cycle of the blue crab is quite complex. So we're going to go over a few of the main steps. So initially, you're going to have two adult crabs, mature female and mature male. We're going to couple to begin the mating process. So when the female is close to her final molt, at least one male, occasionally more than one male, will inseminate her with sperm packets while she is soft. When she is fertilized, she's going to travel south toward the mouth of the bay. In about 2 to 9 months, she starts to develop what's called a sponge, or it's her egg sac. And she's considered a sponge crab. Once she's at the mouth of the bay, she does release those eggs after about 2 weeks post the sponge development. In this first larval stage, they stay in that coastal ocean for about a month. In the second larval stage, they're transitioning back into the bay. And then as a juvenile, they're going to settle within the shallow seagrass beds within that bay. As you can kind of see here, there is a size reference for the planktonic stages to the juvenile stages. It's not to scale, but it does give you an idea of those size differences. And again, once those juveniles settle into the grass, they start to molt progressively until they reach maturity and the cycle repeats.
All right, so Pearl's Blue Crab Survey began in 1967 with George Abbe. So the survey was originally started to research the effects of the Calvert-Cliffs nuclear power plant on blue crabs. So now we're still completing the survey, and it is the longest scientific blue crab study in the Chesapeake Bay, and is led by our mentor, Dr. Tom Ivey. And then a reference to where our survey sites are. So it's our map of Maryland, and the little box is Calvert County, where you are. And then where it says Chesapeake Bay, right where the sea is, it's going to zoom in. And our 3 bay sites that we place crab pots at are Kenwood Beach, the plant site by the power plant, and Rocky Point.
So we wanted to review the blue crab fishery in the bay as well as landings. So the blue crabs are valued as they're the most highly valued commercial fishery in the bay, representing a really high proportion of national blue crab landings, if not the highest. If we take a look at this figure provided to us by Caitlin Ritchie and Scott Kanaki, thank you very much. We see a nice time scale here from 1950 until more recent times. And then on this y-axis, we're going to see dockside value. So in orange, you can see the progression of the value of the blue crab fishery. And as you can see over time, it is kind of exponentially increased, as well as kind of in response to the decline of the oyster fishery. The blue crab fishery did peak over 80 million US dollars, and that is in 2012 dollars. So we can kind of assume that even now it could be of higher value. But there are also additional interesting dynamics happening in the fishery. So what we're looking at here is annual commercial landings to effort over time bay-wide. So on this x-axis, we have our timescale again, 2001 this time until 2019. So this is more of our recent 2 decades. On our y-axis here, we have landings, which is measured in bushels. That's about 84 crabs per bushel. On the second y-axis, we have effort. And effort is how hard these crabbers are fishing to get these animals. So in the beginning of the time series, in the more early 2000s, you can see that blue crab catch or landings were much lower and effort was higher because the crabbers had to work harder to catch these animals. And it is interesting that even though catch was low, they were still putting a lot of pressure on this fishery. In 2011, management changed and blue crab landings increased again. And effort then decreased because the crabbers didn't necessarily have to work as hard to catch the animals. What's notable is toward the end of the time series and more recently, you can see that catch is declining again or landings are declining again, but effort isn't really following the same trend that it possibly has historically. It is not going back up, it is also decreasing, which could suggest there are changes happening in the fishery as well.
So about 30 years after the blue crab survey started, George Abbe published a paper in 2002 that looked at the decline in the size of male blue crabs at our sites. So,
Someone's unmuted.
okay, I'll pause for a second.
Hang on, I gotta do it on my computer.
Okay.
Time to wake up already.
Yeah.
All right. Fix that.
Yeah, this is a lot of louder.
Stand back.
Okay, yeah, that's okay. All right, so George's paper was published in 2002 about the decline of and size of male blue crabs. This is the key figure from that paper. So on our x-axis, we have the years 1968 to the year 2000. Our y-axis is percent of legal male catch. And please note that there are 3 different y-axis scales. So and the reason this is 5 to 6 inch crabs, 6 to 7 inch crabs, and then crabs greater than 7 inches. So we saw that crabs greater than 6 inches, the line shows that there is a decline in the time that George did this study on. And George was one of the scientists that did warn that our blue crab population was declining, and this was in 2002. And in 2008, NOAA recognized that our blue crab population had crashed.
So we mentioned management a little bit when we were talking about the fishery, so we wanted to revisit that. So as I mentioned, in 2011, there were changes in management. And the winter dredge survey is a survey that's been one of the primary focuses for those management decisions. The winter dredge survey takes place during the winter months, and it assesses the blue crab population while they are in a state called torpid, or similar to hibernation. Kind of in contrast, our survey looks at a different time frame. So we're looking at the crab population while they're active from the spring until the fall. And we see that these two surveys could really complement each other because it would really help kind of paint a more full picture of the annual abundance of the blue crab.
So for our data analyses, the first question that we asked was, is the abundance of large male crabs still declining? So again, we're looking at George's figure from the paper that he published. Our year is 1968 to 2000, and then the percent of legal male catch. So to determine, is it still declining, I had to recreate George's graph to make sure that we were using the same data. And there's an orange overlay on here that shows I was using the same data. And at that point, we extended the graph. So we saw that the slope of each different size category did become more gradual. So 5 to 6 inches, 6 to 7, and greater than 7, the slope became more gradual with a linear fit. But a linear fit wasn't the best model to show what's happening once we extended the graph to 2019. So the best model to show that was a lowest curve. So a lowest curve basically takes an average or like a subset. So it'll take like a section and it'll do that for the entire line and smooth for the whole curve or for the whole model. So now we have 1968 to 2019, and these points right here are the year 2000 when George's graph ended. So in the beginning, for crabs greater than 6 inches, you can see the decline was a very linear line. So it's more like a straight line. And then in the early 1990s, this was before George's original study ended or paper ended, the curve ended up flattening. And what's happening there is that crabs greater than 6 inches are approaching a limit of possibility. So our catch is getting closer and closer to zero. You can only get so close to zero so fast. So it's still happening, just happening slower.
So our second question was, how do environmental factors affect the blue crabs that we are catching? So to explore this, we used a certain method called a principal component analysis, or PCA. So what a PCA does is it takes a large data set with many variables and it reduces it to an ability that's more workable. So this is also preserving as much information as possible while doing this. And it plots relationships or correlations among many of these variables on a two-dimensional graph. So it reduces dimensions that allows us to interpret the data and relationships between that data in a better way. So this is what one of our PCA analyses looked like. What we would do is we would take one dependent variable and look at it in regards to many independent variables. So here, the one dependent variable we are focusing on was our yearly total CPUE. What CPUE is catch per unit effort, or average crabs per pot. So when we pull our crab pots out of the water, it's the average number of crabs that are going to be in that pot. The independent variables were many environmental variables, such as salinity, temperature, and Susquehanna flow. And how you can interpret this is the vectors that are more closely together or more closely oriented are more positively correlated or have a more positive relationship. Whereas when they are pointing in different directions, they have a more inverse relationship. And this seemed to make sense to us. For example, if you look at salinity here, these two vectors, they're closely related. We have one that's taken in the spring and one that's a yearly mean. You would assume that the salinity would be related with the other salinity. Now, it's inversely related to flow. Susquehanna flow is fresh. So when there's more flow, salinity is lower, and vice versa. We also looked at an individual's PCA, which allowed us to look at individual years and how they're related to one another. points that are more closely grouped are more similar. So we saw that in the 1970s, these points were really closely grouped, suggesting that they were less variable and those years were more similar. Now we also saw that the early 2000s were also grouped, a different group, but also suggesting during that time period, similar things were happening, less variability. What's interesting is the 1970s group and the early 2000s group, again, are different from each other, suggesting that over time there has been change in the population. So after doing our PCAs, we did start our environmental analyses. So this is one where we looked at AMO, which is Atlantic Multi-Decadal Oscillation. It's a measure of sea surface temperature in the North Atlantic. And here on the x-axis, we're looking at annual average AMO. On the y-axis, we're looking at our total yearly catch, or crabs per pot. So on the annual average AMO was more negative, how we interpreted it, we saw a higher catch. When the annual average AMO was more positive, we saw lower catches. Also to note the time scale here, so the points that are darker are earlier, and the points that are lighter are more recent. So you can see that progression of time as well as the annual average AMO becomes more negative to positive. So it did suggest to us that in terms of thinking about the future, the annual average AMO can, have some influence on our catch.
All right, so Amanda introduced you to our ocean temperatures, but we did also look at Chesapeake Bay temperatures. So this y-axis gives our spring total blue crab catch. So our spring catch of males and females, and then our x-axis is our temperature z-score. So z-score, we use that just to make it easier to compare to other variables, but it is a measure of the variability from the mean. So this is the mean for all of the years from 1971 to 2019, and we have negative values which are less than that mean and positive values that are greater. So we saw that there was a weak relationship, but still a positive relationship. So the greater the temperature, the greater our catch. The years 2011 and 2019 were influential in driving that relationship. And also mentioned was salinity. So we looked at our yearly sponge crab catch compared to our yearly median water salinity. So our salinity z-score, again, just the variability of the mean of our salinity, and then our sponge crab catch. And it's another weak relationship, but still positive.
So our third question was in regards to landings and whether we could predict landings with our certain catch indices. So we looked primarily at our fall index, so our catch during the fall, and whether that could predict landings of the following year. So this first figure is looking at our total fall sublegal blue crab catch. Sublegal crabs are under 5 inches to our total spring Maryland Bay landings. So on the x-axis here, we have our sublegal catch. And on the y-axis, we have the following spring Maryland landings. So as you can see, it's a reasonably good positive relationship. And that was interesting to us. And we wanted to know if we would see something similar Bay-wide. So again, this was just in Maryland, and the Bay-wide analysis was Maryland as well as Virginia landings. So similar analysis, we're looking here at the total sublegal catch to now annual Bay-wide landing. So we also expanded our time scale. We actually found that the relationship was even stronger here, which was very interesting, possibly suggesting that our fall total sublegal catch could potentially have some ability to predict the following spring and annual landings in the Bay.
All right, so our implications or conclusions for the questions that we answered. So first, our first question, is the abundance of large male crabs still declining? And our data does suggest yes, that crabs greater than 6 inches are still decreasing. Despite management changes, we are seeing less crabs greater than 6 inches in our catch. And our second question, how do environmental factors influence blue crab catch? So temperature and salinity separately do have a relatively weak relationship with our catch, while the AMO and our catch have a stronger relationship.
Lastly, again, does our data have any ability to predict commercial landings? What we looked at again suggests yes, possibly. Our fall sublegal CPUE did have a pretty nice positive relationship with landings of the following year, both Baywide and within Maryland. And one of the important things about that is it does allow us to think about the potential our survey might serve in terms of management for the blue crab within the bay. So some of our next steps in future research, as we mentioned, this is a 50+ year study that has a very large amount of data. So not everything has been input into our database yet. We have some great temperature, salinity, and DO data that we didn't get a chance to enter, but would love to use it in the future to do some of those environmental analyses to see if we can find any stronger relationships or any different relationships. We also wanted to look further into some of the subsets of the population. We mentioned sponge crabs and how that was in fact affected by environmental factors. Juveniles, another subset. The winter dredge survey, like we mentioned, one of the surveys that looks at the blue crab population as well, did note that this year was one of the lowest years for juveniles. We also know that juveniles do have a relationship to submerged aquatic vegetation, such as seagrass. And so exploring that analysis with our juvenile data as well could be interesting. And then, as we had also talked about torpid, or when the crabs hibernate over winter, there can be mortality. So seeing if we can estimate that mortality while they overwinter would also be an interesting analysis.
All right, and a big thank you. Thank you everyone in person and on Zoom for being here today. And then special thank yous to our mentor, Dr. Tom Ivey, our statistics consultant, Dr. Elgin Perry, Kyle Wood and Zafia Galvin, who are previous interns that did enter the data we were able to use. Dr. Amanda Knobloch for putting together this seminar today and additional support when we needed it. To Pearl and Dr. Scott Kanaki for making the Blue Crab Survey and Amanda's internship possible, and Dr. Chun-Li Fan for making my internship possible.
We also wanted to acknowledge our data sources. So thank you to Morgan Pearl for the Blue Crab Survey data. Thank you to the Chesapeake Bay program and the Chesapeake Biological Laboratory for our environmental data. And we wanted to thank the Maryland DNR as well as NOAA for our landings data.
Well, and now we'll take any questions, and please enjoy our beautiful survey pictures
From when we were in the field.
Yeah.
Hi, how are you all doing?
Good, how are
Good,
you?
thank you.
Hi, this is Bill Yates. I used to work at the Pearl. I did work with George in the past. One of the things they talked about, and I never saw any paper on it, was during the fall female run down the bay and the subsequent release of the eggs, there was some suggestion that if the winds were predominantly blowing down the bay during that time, that they scattered the young out toward the ocean. Whereas if it was predominantly on shore, it kept them in the bay. Have you seen or heard anything of that as far as your environmental factors?
So it's not something that I personally was familiar with or looked at in depth during this internship, though it is really interesting, especially thinking about sponge crab dynamics. That's something that was very interesting to us. And I believe that both Amber and I would love to explore that further. And of course, hopefully do further analyses to look into that. But that's a really great thought to move forward on as well. Thank you. You have anything to add?
I was just saying, yeah, that's a great topic to explore.
Yeah.
I haven't read anything on that, but that's definitely something that we should consider when moving forward with our sponge crab environmental analyses.
Yeah, absolutely.
So I have to ask, because in my neck of the woods, what a sponge crab is probably very different from what you call a sponge crab. What are we talking about here?
So a sponge crab is a female crab who is mature.
With eggs, okay.
This one.
Yeah, who's been fertilized and has developed her egg mass.
Okay,
Mhm.
okay, thank you.
So,
Yeah, because in the Caribbean, that is a type of decorator crab that takes a
Ah,
sponge and carries it.
very interesting.
So I was really curious to see whether those pieces were there in the Chesapeake.
Oh, yeah, no, thank you for sharing that.
Okay, thank you.
Yeah, go
I
ahead.
just wanted to amplify what Bill was talking about, Bill Yates. Something you showed with the Zoea
Mhm.
are here. And they're obligated to go to megalops out into the Atlantic. And there's a whole different, I won't say whole different, but the stressors are not the same stressors in Chesapeake Bay.
Yeah.
They're, I don't know how, I mean, obligated, but that's part of that lifestyle.
Mhm.
Life science cycle. So I think it is really important to look at what other factors were happening there, affecting the return back to the bay mature.
Yeah, absolutely. And I think another point of interest for us that we do want to explore further are those, occurrences that happen in the coastal ocean that do influence juvenile recruitment back into the bay. It's super important, especially seeing how the juveniles, status is currently looking like. So yeah, absolutely. Any other questions from Zoom?
Just one more observation. I've heard that, when the females spawn with the male, they're left, as you call, the sperm sacs, that females could have up to potential 3 cultures of eggs. Is there anything written or anything out there that you guys know of that suggests that smaller males cannot leave them with as much sperm as a larger male?
We don't have any research on that, but I know that CERT did complete a research study on sperm limitation. So the Smithsonian Environmental Research Center did look into that. But that is one of the studies that is done on whether smaller males do have sperm limitation.
Yeah, given that, the large crabs or the large males have been declining.
Yes. Yeah, very interesting. Thank you.
How often did you guys get pinched, by the way?
I got pinched the most.
Amber got pinched
like
more.
every time.
It's stung. It's just
Oh yeah, the
joys of the bay.
And I would get pinched through the glove too. It wasn't like it was just how. I don't even know how.
Yeah.
But yeah, so it was a good experience. Yeah, humbling. Yeah.
Okay.
Yeah, well, if we don't have any other questions, if you think of any, those are our emails. You're welcome to email us with any questions or thoughts or suggestions that you have.
Absolutely. We would love to hear any input. So
Thank you.
Thank you guys so much.